So the question will give you a matrix, and then you have to return the elements in certain pattern. So what is the pattern? They give you all the diagonals in this way, and then you have to return in this way. For example, you have the elements 1, 2, 3, and then you have to return 1 is the first diagonal, 4, 2 is the second diagonal, 7, 5, 3 is the third diagonal, 8, 6 is the fourth diagonal, and 9 is the fifth diagonal. Okay, let's go to see another example. So in this matrix, not all the elements exist. So you got the input like this. So for example, the first row is like this, and the second row is only 2 elements. The third row is only have 1 element, but you still have to return the elements according to the diagonal. For example, the 1 is the first diagonal, and 6, 2 is the second diagonal, and 8, 7, 3 is the third diagonal, and 9, 4 is the first diagonal. Okay, that's the point, because between the 9 and the 4, there's nothing in between. So you have to return 9 and immediately 4. So how we are going to solve this problem? So we can make another example. Here is a matrix. Now we want to make this matrix not perfect like this. We can remove this, and we remove this. And how can we return the elements? So when we return the elements as the question required, we have to return according to the diagonal. So the diagonal is like this. All right. So in this way, you are going to return. Firstly, you are going to return this first diagonal. So you're going to return 1, and the second diagonal is 5, 2, right? And the third diagonal is 9, 3. And fourth diagonal is this one. And then later you have to return 14, because 14 here. So the 14 here, the 14 is belong to a diagonal. There's no other elements in the diagonal. So 14 is the only elements in this diagonal. So 14 is where it exists alone. And then the next diagonal is this one. So it's 15, 12, and the last diagonal is 16. So that's the pattern we're going to return the elements. So there are a lot of empty slot here. We have to skip. There's a new index that we can pay attention to. What's the meaning of that? Okay, so for 6, the new index is 1 plus 1, so it's equal to 2. For 3, the index is 2 plus 2 is equal to 2. And also for this index, for 9, the index is 2 plus 0 is also 2. So this is the new index. The new index equals to row plus column. That's how we can find the pattern that they belong to the same diagonal. Okay, let's make another example. So for the 14 here, the new index is 3 plus 1 is equal to 4. All right. For the 11, the new index is 2 plus 2 is equal to 4 as well. Okay. And for 8, the new index is 3 plus 1 is 4 as well. So all the 3 elements, they are in the same new index, which is row plus column. So it means that they're in the same diagonal. So that's the way we find the diagonal elements. Okay, so we are going to solve it with a hash map. The first step is that we're going to scan all the elements. We're going to test all the elements and find their new index. And after that, we will put there in the hash map. Oh, so this is the key. Okay, so this is the value. So for example, the 14, the key is 4, right? So I'm going to put 14 here. and 11 here, 8 here, because their new keys are all 4. And then if I want to check this one, okay, this diagonal, their new key are what? Are 2. So we're going to put in the same connection, I mean for the key. Okay, let me repeat again. So this is the key, this is the value, each key's value is a collection of integer. Okay, now let us scan for all the elements, see how we solve this problem. If we are checking this element, so the key is 0, so we put a 1 here. This key is 1, so we'll put a 2 here. This 2, just 3 here, 4 here, and that now we're going to check this one. So now we're going to check 5. The 5 actually is in the same key as 2, so the 5 should be put in here, right? So I should put 5 here, but bear in mind that the diagonal direction is in this direction, right? We have to start from 5, so that's the reason why. So actually we have to put 5 in front of 2, right? Because this direction we have to start from 5, so we already put the later elements in front of the earlier elements. So now we're go to 6. So 6, the new element is 2, so the 6 should be here, right? And 7 is 3. We should put 7 in front of 4, right? So it's 7 is here, 4 is here, and 8. The 8 is 4. The 8 new thing is 3 plus 1 is 4. Okay, so it's 8. And now we go further. It's 9. 9 is 2. We should put 9 in front of them. And 10 is 3. We should put 10 in front of 4. And 11, we should put 11 here, right? 12. So the 12 is the index is 5. So the 12 is here. And now we 13 is 3. So 13 should be here, right? And 14 is 4. 14 should be here. Okay, let me change another color. So 14 should be here. 11, 8. This one is 5th, so should be here. So the last one is 16. So 16 is belong to the index. What is 6? So only 16 belong to this index. So this is another diagonal. So here you can see this 0 to 6, they belong to a new index of the diagonal. So you can see here the index 2 is 9, 6, 3. So it's in the right direction, right? 9, 6, 3. And this one is a 13, 10, 7, 4. So it's also in this direction. So that's the way we return from 0 in this way, right? So the index for the diagonal is this one is 0, 1, 2, 3, 4, 5, 6. So now we have the hash map, and we have all the elements in the hash map, and then we just need to get the key from small to large and get the value out and insert to the result by sequence, and then we can just return the result, and then the question will be finished. So firstly, we have the code signature is here. So the input is a list, is a 2D list, and then we need a map as a hash map as we mentioned before. So the total means the total number of the element. So the number is not a 5 multiple 5. It's actually there are a lot of elements missing. Okay, now we're going to using this to scan all the elements from row and to column, and then and each time we're going to get the total numbers by adding the each row's number, and then by row, by column, and then we get the new index, and then we will see if the new index if it exists in the map. If not, then we're going to put a new array list. So assign a container to a new index, and after that, we find the elements points to the new index, and then add to the hash map. So let me repeat again. So the map have the key is the index, and then the index will connect all the elements that belong to the index. Remember, this step is to prepare the hash map. So this step is to prepare the hash map, and this step is to try to build the result. And firstly, we initiate the result content container, and then we scan all the elements in the hash map, and then we get all the keys values out. The value is a container, like R, and then we get each element out from the container and assign to the result. Okay, so the code here is a little bit different from what I have explained earlier. So in this example, the key 2, I mean, in this one, when the index is equal to 2, and the element is 378, the 378, right? When we prepare the hash map, the container, the element should be like this. However, we need this. We need to just reverse the direction. So this is what we have at this moment, and this is what we need. So that's why when we get the container and get this out from the hash map, and then we get this out, and then we start assign the value at the end of the container instead of from beginning. So that's the way we can reverse this container's elements in this sequence and assign to the result. Okay, and yeah, and after that the result is ready, and then we can just return this result